Hello, my name is Mateo Jelenkovic, and this is Lab 5 Conservation of Energy in Real Systems for Physics 2211. So, for the introduction to this lab, I used the tracker to model pool balls on a model Newton's cradle from rest. And using both the conservation of momentum and energy, saw if energy is lost to the surroundings. And I found energy lost to the surroundings and determined where that energy went. So for our key concepts, we have kinetic energy, potential energy, and conservation of energy. And then the system was the ball and the strings, and the surroundings were the air and the atmosphere. And it's a little blurry, but there's a picture there where it shows this model. So for our tracker data, um, sorry, it's a little blurry again, but it um basically it was basically curves and sine curves, so you could see like the x and y position of each and how it was affected. It was basically like a cradle, like the name. And the original distance was 0.12 meters. And for our initials, or not our initials, the max height, as highlighted in blue here at time 0.67, was 0.73 and then negative 10. And then at time 1.3, it was negative 0.11 and negative 0.12. So we use these numbers to calculate energy loss due to sound and vibration. So I started with delta K plus energy of vibration equals 0, and then flop the sides, and then just solved for um, delta K, which was the V final minus V initial times the mass times negative 1/2, which gave us the energy of vibration, the amount lost due to that. So after that, we went on to air resistance and how much energy was lost because of that using the conservation of energy and our max height from 2 slides ago. So I just went through, did the conservation of energy, put all the values in, and then I knew V final was 0 because max height, V final was 0, and then height initial was 0. So I found that using this, that the energy loss was 0.1722, and using that found that the, or using, not the energy loss 0.722, using that found the energy loss from the potential of derived minus the potential of real, which got us 0.02249 joules from air resistance. And the total loss was 0.17865 from that. And here's a clearer picture of the tracker data. What does this mean? So basically, the conservation of energy is real, but in real life, it does not stay in the system. Energy dissipates in multiple ways through sound, heat, and air resistance, which is why perpetual motion is impossible. But what if we had more balls? If we had more balls, more energy would have been lost due to the increase of surface area and friction between the balls. And to conclude, the lab was successful and we successfully calculated how much energy was lost. So thank you.